In this video, we're going to look at an instrumental method of analyzing things called flame photometry. It's based on flame tests. So if we look here, we're doing a flame test on some sodium chloride. So we've got a dish of sodium chloride, put some in the flame, and we get in the Bunsen flame, you get the characteristic yellow color associated with sodium. Likewise, if you get some pure potassium chloride, put that in the flame, you get the characteristic lilac color associated with potassium. You've identified the positive ion present in that substance. However, what flame tests are not good at dealing with mixtures. So if you've got two or three different substances present in the flame, then in the substance, your eye can't distinguish all the different colors that are being given out by the flame. And it's particularly so with if you're using sodium. Okay, so here we've got a mixture which is mostly potassium chloride with just a small amount of 5% sodium chloride. If you put that into a flame test, you'll just see a yellow flame. The sodium, you won't notice the lilac at all. The sodium color is much more intense, and it kind of swamps out everything else, and you can't really see anything there. So flame tests have got their limitations. But what flame photometry does is it lets you deal with mixtures quite easily. So instead of just looking at the light with the eye, what happens is you have and in that you have a prism which can split up all the colors of light into the different colors of the spectrum. Okay, and that will be outputted you can either take a photograph. In old days it would be a photograph, and nowadays it will go to a computer and you'll get a digital photograph of the spectrum. Okay, so if you look at light from the sun, white light, of course, is a mixture of all the different colors. If you look at light from the sun, you'll see a spectrum, something like that. Okay, so this shows you the wavelength of the light. So at 450 nanometers here, this is the blue part of the blue violet sort of thing, and the longest wavelengths of visible light are just over 700 nanometers there in the red part of the spectrum, and all the other different wavelengths in between. And as I say, white light from the sun, there's more or less every color, every wavelength is represented, and you can see a continuous sort of rainbow. Now, if you look at light coming from one of these flame tests, if you analyze that, you don't see a continuous spectrum. You see a series of lines, which I've got down here. Right, you see a series of lines like that. So there's a spectrum of different compounds containing either lithium, sodium, potassium, or calcium. So you can see sodium, for example. It's most of the spectrum is actually dark. You don't get those colors produced. You get a very strong yellow line around 600 nanometers. That's characteristic of sodium. And you also get like the red line there, which you don't notice with the naked eye, but you can see quite easily when it's split up into the spectrum. Also interesting to note here that you'd never confuse that spectrum with that of lithium, because that red band for lithium is of a slightly longer wavelength than the sodium. It's not characteristic. And likewise, lithium has got that blue band there, which is absent from sodium, and the orangey yellow band produced by lithium is also a different wavelength than the sodium one. Potassium, you can see here you've got a series of blue lines in the violet part of the spectrum, which gives potassium its characteristic colors. You don't really notice. Look with the naked eye, you don't notice that it's also giving out some of these green colors here. And likewise, calcium, right, you've got a mixture, a whole series of bands in the red part of the spectrum, series of yellow bands, and one rather thick green band. So if you had a mixture, for example, of say calcium and sodium, if you just looked at it with your naked eye, you wouldn't see anything. You would just see the yellow color of the sodium. But if you looked at the spectrum, you would see that you had, all the calcium colors, but you'd have all the sodium ones mixed with it. And you'd be able to tell you have a mixture of calcium and sodium. So just to finish off, let's have a look at, this was an exam question, AQA, right? Right, so they gave you not printed in color, only printed in black and white, and they don't give a a scale here, but it's going to be wavelength. So you've got wavelength is along that axis, and it'd be about 400 nanometers down here, up to about 700 nanometers up here, the red part of the spectrum. Right, so it gives you it for calcium, copper, potassium, lithium, and sodium. You should know all the colors of those from those flame tests. And here you've got a mixture of the two metal ions. Now, what can we say? Well, just looking at the right-hand part of the spectrum first, I can see that that band there, lithium, that's obviously represented. So it looks like there's, I'm going to say there's lithium in there. Let's double check that. So we've also got that, which would be kind of in the orange part, that band there. Yeah, we've also got that. So that's looking good. That's lithium. What we haven't got is, right, we've got all those bands there, that which is down in the, that's kind of the bluey part of the spectrum. And where is a good candidate for them coming from? Right, it could be sodium. Right, that's got a load of bands there. But, so, yeah, I would say that is probably right, because sodium has also got this yellow band here, which is represented in that spectrum, yeah. And just to confirm, yeah, so you've got that. I think that would probably be an orange color, this band here. That's in the lithium, that's in the mixture. So I think the mixture of the two metal ions is definitely lithium and sodium. So that's how you'd use flame photometry. And just to finish, they're quite from the advantages. Okay, so advantage of flame photometry, which is an instrumental method, and disadvantages of it. So we're comparing that to compared to, so this is flame photometry against just a simple flame test. Well, the advantages of flame photometry is you can deal with mixtures. You can't in a normal flame test. You can deal with very small sample size. You hardly need any. But the disadvantage, I suppose, that it requires expensive equipment. That is the main disadvantage. Whereas flame, you don't really need anything for a flame test. And I suppose also you need some skill, more skill in running a flame photometry test. You have to know how to work the machine, rather than with a flame test, you don't need that. So you're quite likely to get questions comparing instrumental methods with test tube methods, and you can always use those sort of arguments there.